into the drainage trench. You could have a drain tile line that could be placed in the seepage trench and connect that to the existing storm sewer system. In some existing green areas, for example ponding areas, you may just not even have that, and when the seepage would come upward, it would tend to pop that 6-inch topsoil layer off and seep upward into the ponding areas or other places where it's chosen to forego the drain tile line. It's important to note though, this is focused on the levee. Basements on homes on the land side that maybe in the past and potentially the future were and could still be subject to seepage and groundwater flooding even after these corrective measures. We're kind of cutting off or mitigating the seepage pressure on the levee, but that doesn't mean that a house on the land side with a basement, the water is still going to seek its own level. So if you have a basement that penetrates through that clay layer at the surface, that's still kind of providing a way for the water to try to seek its own level with the flood level. And that obviously is an unfortunate thing for a basement. Now, this is kind of a brightly colored plot, but Highway 43 is running there, so northward is up. The blue areas are where we're recommending some sort of mitigation for the levee, and this is a stretch of seepage trench. Here's a zone where it's adding, I think, 1 to 2 feet of fill makes a big difference in providing enough weight to counterbalance the levee or the upward seepage. There would be the seepage trench along here, spot there. So we had this fill area. The rest are seepage trenches, except for along Levee A here, and I think this is Highway 16, going west. Yep. There's another area there where the ditch could be raised, I think, a couple feet, and that would provide the counterbalance weight, and it would save a fair amount more digging to get through the clay layer than the amount of fill that you would add. So there's a spot where it's reasonable to fill it. Just kind of to highlight several of these spots. I mean, this is adjacent to a ponding area. That's adjacent to a ponding area there and here. And again, ponding areas down in this region.
Yeah, and I think the one thing I'd like to add to this is, you know, when we were here about 6 months or so ago, you know, we had kind of some preliminary findings which were based on our initial looking at the soils, and we had much more extensive, you know, at that time we were directed, you know, go back, sharpen your pencils, see if there's a way, you know, you can cut down, you know, the disturbance, the cost, all that. So we did in fact do that. You know, we kind of looked at some of these questionable areas. You know, American Engineering went out and did more borings to kind of really clarify what the soil properties and that were there. You know, with that we were able to come back and, you know, reduce the extent and size of these. And at that time, you know, we were looking more at well systems to relieve the pressure, you know, which would have cost, you know, several times more than what's proposed here, and, you know, would have probably required special contractors. You know, I think this system here is going to work, but, you know, based on the initial or additional looking at it, I think we've cut down on what was initially required. So with that, then we'll get into some of the some of the freeboard discussion. This part of the levee, the north part here, Highway 43 coming into town from the north, is part of that levee system. There's approximately 800 feet as you come into town. You'll notice there's a slight dip in the road before you come up close to the bridge. You can kind of see it here. If we draw a horizontal line from the bridge off to the north, there's an area there where it's about a 1.5 feet too low for about 800 feet. So because of that, that part of the levee, you know, the Highway 43, which is part of that levee, does not meet that freeboard standard. So that will have to be raised to provide the protection that we need. There's a part of the main levee system near town here, near the DNR Railroad Bridge, that's slightly too low. You know, you can see it right here off on just on the north part of the bridge. It's a relatively small area, and it's only about 1/2 foot that needs to be raised. So that's a fairly minor effort. The Root River levee system meets all the standards, so that's high enough to, you know, elevated high enough to meet that standard. There's as you look west, heading out of town, out of 16 towards Lanesboro, there's a small ditch section here that the operation and maintenance plan says should be sandbagged. You know, I guess our recommendation is when you get the flood happening, you know, your maintenance crews have enough things going on, you know, let alone worry about getting sandbags out to this small area. So again, since this is such a minor cost, our recommendation is, you know, just fill that in. That's one less thing that the folks maintaining, you know, trying to run pumps and open gates have to worry about during that time. We didn't specifically look at the DNR Trail Bridge as part of this project. I know that's kind of been a topic down here, and you know, we've had questions asked of us on that. Our evaluation, our hydraulic evaluation, or floodplain evaluation of Rush Creek used a model, and that model was developed by the DNR and Corps of Engineers. You know, we reviewed that. Based on that evaluation, the bridge itself did not cause flooding during the 2007 flood. That if that bridge had been completely out of there, the levee still would have overtopped. It was that much rainfall, and there was that much water flowing through there. In terms of this, in terms of the certification for the levee system, that bridge does not unduly affect the flood levels. You know, so it is not a critical factor. It's not something that has to be replaced to meet FEMA standards. It generally withstood the 2007 flood. There was some erosion on the button. You know, there's some discussion about a possible long-term replacement for that. In terms of the cost for corrections, we've got two tables here. The first one is a required improvement. So these are improvements that would need to be done in order to meet FEMA standards. The next slide is some of the recommended improvements. They aren't required to meet FEMA standards, but we're thinking they're good ideas and something the city may want to consider. So the table here has the various levee systems. So levee A and B is the big west system, which protects the main part of downtown, the area we're in right now. There's about 160 buildings in this area that it protects. There's 4 needed improvements there. The first is to raise that levee by the bridge, you know, that minor amount of raising. You know, just pull off the topsoil, put some fill in there, put the topsoil back. We're estimating that would be about $6,000. There's the other 3 are what Joel talked about, to control the seepage. So there's an area south down there by the Quick Trip where there's going to be a little bit of fill in the ditch. The rest of it is the trenching through town. Levee A and B is this main part of the levee system is just divided into levee A and B. Levee A is the south part, levee B is the north part. Right there.